Welcome back to True North Mechatronics. In this episode, we're finalizing the 3D printed architecture of the SparkBot version 2 by engineering the final locking hardware for our Vetronics Enclosure. We've built a robust protective electronics bay that acts as a structural compression member, but right now it's just resting on the chassis. We need to lock it down. We're going to design two close-fitting rear stop blocks that anchor directly to the back of the mobility base. These blocks act as the final immovable wall for our enclosure to press against. We are also integrating a sliding latch mechanism directly into the top of these blocks. These latches are engineered to glide smoothly forward, locking securely over the flanges we added to our enclosure's side panels back in part 13. Design, engineer, deploy. Let's get to the CAD. Begin by creating a new body and a new sketch on the XY plane. We're going to use the poly tool and we're going to sketch out a profile here, beginning with a segment on the x-axis. In fact, I think I'm going to set the dimension for this one first, just to give us a sense of scale. It's going to be symmetric around the y-axis, and this will just make it easier for us to build out a profile without FreeCAD twisting us all around the place. So let's bring a vertical line upwards. We're going to go over horizontally to about right here. We're going to come back down. I'm going to move that constraint. We're going to come back down, small distance, and over. We're going to close this shape here in a minute with an arc. Let's constrain these other shapes that we've created though. So constrain that to 22.5. Let's constrain this to 11.5. This one down here is constrained to 4.5. And we'll constrain this small horizontal segment to 2 millimeters. Great, so now let's grab that arc tool. Let's grab create arc by 3 points. Let's select our two endpoints there and right click to clear our tool. Let's constrain this arc at 20 millimeters, and that does it for the initial profile for our stop block. So let's close out of this, and we're going to pad this shape out to 5 millimeters. All right, now we're going to add two mounting holes plus a retaining hole that will hold the latch on the top of this. So let's left click on our shape here and create a new sketch. So we're going to create 3 holes here. 1, 2, 3. They're all going to be collinear, so select the center of all 3 holes and set them so that they are horizontally aligned. There we go. They're all going to have the same outer diameter, so we'll set those as equal. And we'll set that outer diameter to 2.8 millimeters. All right, so now that we have that, we're going to create a point-to-point distance between our two mounting anchor points at 8 millimeters. And the distance between this one and our latch retainer is going to be 5 millimeters. So now that we have that, we're going to constrain this group of circles with respect to this front edge. So let's set this at 7.25 millimeters. And our 1 degree of freedom now is going to be the offset from the bottom here. So we can use this corner here as our reference. And let's give this an offset of 4.25 millimeters. Okay, and so with that, our 3 anchor points here are fully constrained, so we can close out of the Sketcher workbench, and we're going to pocket this all the way through our shape. There it is there. And now what we're going to do is we're going to add a shoulder onto the edge here. This is going to be a guide rail so that the latch is able to slide along this shoulder as it's moving forward on top of the flange. So we're going to reference this arc, and we're going to reference this back edge. And let's use the polyline tool, and oh, polyline tool doesn't work with that. So we'll just grab the single line segment tool, and we will just bring this down and over. Excellent. Let's constrain the width of our shoulder here to 3 millimeters. And we need to complete the arc in order to close this shape. So I'm going to deliberately exaggerate the arc on that so that FreeCAD doesn't inappropriately constrain it. And that's going to be set to 20 millimeters radius. So our shoulder profile is fully constrained, so we can close out of this, and we're going to pad this shape out to 3 millimeters. So now we need to reinforce this hook back here. This hook keeps the enclosure sides from sliding out the back of the chassis. So we're going to click on that corner there, and we're going to give it a fillet, and that fillet is going to be 1.5 millimeters. We're going to add a fillet here. We need to create some clearance here, and we need to get rid of this knife edge here. The handle for our latch is going to sit right here, and if this knife edge is sitting right there, it's possible to end up cut on it. So we're going to round over this to protect our fingers, and we're going to also round over this edge because as the enclosure sides come down, that sharp corner there hits the side, the back corner of the enclosure. So we're going to fillet those over, and we will fillet those at 2.5 millimeters. That protects our fingers, and that creates clearance. Now we're going to create fillets on these, and what's going to happen is we're going to get a predictable fillet here, but this one's going to fillet all the way around the outside. And it produces a nice effect. Let's give this a 1.5 millimeter fillet. Let's try that again. 1.5 millimeter fillet. Let's have a look at that. There it is. So our fillets give a fairly pleasing profile there. And so that will do it for the left-hand side. Now we also need a right-hand version of this. It'll sit on the right-hand side of the SparkBot. So we're going to rename this one to left base. And now we're going to drop into the draft workbench. And we're going to use the clone tool. And here on the scale, we want to reflect this around the x-axis. So let's set our scale on that to -1. And then let's translate this along the y-axis so that we can see what this looks like. Actually, let's bring it over on this side. And I'm going to just rotate this around so that we can get a clear view of the fact that we have a mirror copy. There we are. I'm happy with that. So I'm going to accept that. So there we are. So we've got mirror copies of each other. So we've got a left-hand side and we've got a right-hand side. I guess I should call that the right base. Okay. Now we're going to return back to the part design workbench. And I'm going to hide both of these parts. All right, we're going to select the top level, and we will create a new body here. And then we will create a new sketch on the XY plane. And for this sketch, we're going to begin with a rectangle, and we're going to make it symmetric around the origin. And this is going to have a slot in the center. But let's constrain our shape here first before we add a slot. So 28 millimeters is the horizontal dimension, and our vertical dimension is 8.1 millimeters. All right, so now we can add the slot, and this slot will follow the screw that we have connected into the board. Now, slots in FreeCAD are problematic, as you can see. All we have to do is just move this slot, though, and FreeCAD removes whatever constraints there that is giving it problems. Let's set the radius on our slot here. So that radius is going to be 1.5 millimeters. Let's set the length of our slot here to 15.5 millimeters. And now we are going to offset it with respect to the left-hand side here. So let's offset it from the center to this edge, and that offset is going to be 7.5 millimeters. Okay, so the initial profile for our latch is fully constrained, so we can close out of that, and we're going to pad this shape out to 4 millimeters. Now we're going to add a handle on our latch here on the back. So let's add that sketch there. This is a fairly simple handle, so we're just going to reference that left-hand edge, and with the rectangle tool, we will create a rectangle that is coincident with the end, and it is going to have a horizontal value of 3 millimeters. So fairly simple. Let's pad that out to 5 millimeters. And that's the basic shape of the latch. Now we're going to reinforce this corner here. So this is going to be reinforced with a fillet of 0.5 millimeters, just enough to not give it a hard edge there. We're going to round over the top of the handle that we're going to be grabbing. Those sharp corners at this scale aren't really going to be damaging, but aesthetically it will be nicer to have them rounded over. So let's round them off at 1 millimeter. And we're going to create a clearance on the bottom and a matching aesthetic fillet on the top there. So they're both going to be filleted to 1.5 millimeters, and that completes the latch. Now, the PT screws that we're using will dig into the plastic surface, so we also need to build a washer. So let's rename this part our latch, and now we're going to hide it, create a new body and a new sketch on the XY plane, and we're going to create a washer. Very simple. That is going to have a profile of 3 millimeters. And we're going to give the outer diameter of our washer an 8 millimeter profile. So there we are. There's our two measurements for the washer that we're going to be using. So let's close out of the Sketcher workbench. Let's pad this shape out to 2 millimeters, and let's give it a cosmetic chamfer or fillet here of 1 millimeter. There we go. And that completes the sliding latches and stop locks that for the entirety of the SparkBot version 2 3D printed architecture. By engineering this sliding lock mechanism, we finalized a toolless, highly rigid enclosure that protects our wiring, stiffens the chassis, and forces strict battery safety protocols. In part 17, we're going to step away from the CAD software and move to the workbench for a full assembly video. We will bring all 16 of these printed modules together to build a physical chassis. Chart your course, build your world. I'll see you in the next one.